It's amazing, isn't it? Like you just look up at the night sky and it's just, wow, it's this blanket of stars. It's something so many of us have done and felt. And I bet almost everyone at some point has looked up and thought, just how many stars are actually up there? You know?
It really is a common wonder, and the material you sent over really explores
Yeah.
that, the difference between what we experience and the real cosmic reality.
Yeah, exactly. Because, I mean, it feels like we're seeing tons of stars up there, but like the truth is what we can actually see is just this teeny tiny fraction of how many there really are.
Yeah.
It's like, I don't know, it's almost deceptive how beautiful it is up there, but like the reality is, as we'll see from this research, it's so much bigger,
Yeah. Yeah.
even more awe-inspiring in a way.
It really is. And what's so interesting is that disconnect in scale.
Right.
The few thousand stars we can see are like, I don't know, grains of sand on a beach
Yeah.
compared to what's out there.
Okay, so let's unpack some of that like initial information. So if you're on a really clear night, super dark night, no city lights around. I know one of your articles was talking about the impact of, cities and towns and all that.
Yeah.
The average person with good eyesight, they can probably see like 2,500 to 3,000 stars at any one time from where they're standing.
Yeah, that's about right. From, a single viewpoint, right? Like we're on our end, it's curved, so we're only ever seeing about half of the entire celestial sphere.
So that means, like, if you were able to see the entire sky at once somehow, under absolutely perfect conditions, which, I mean, none of us will ever be able to do, but, like, under perfect conditions, you'd be looking at double that number. So what, like 6,000 stars, something like that?
Yeah.
That's still a lot, right?
It is, yeah.
Okay.
As far as we're concerned, it's a lot. But,
Yeah.
when you think about how big our galaxy is, the Milky Way, and then, you take that and multiply it by the number of galaxies we're seeing in these James Webb images you shared. Those are amazing, by the way.
Yeah.
That 6,000 really starts to seem small. So the main question then is, if there's like billions and billions of stars out there, why can't we see more of them? Like, what is stopping us?
Yeah, like what is preventing us from seeing that huge cosmic show? So let's dive into those reasons. So drawing from your research here, I'm guessing the first thing that pops into everyone's mind is light pollution. I mean, even a little bit of artificial light can, wash out the view of fainter stars.
Absolutely. That's a huge factor. And
Yeah.
as your research probably detailed, that glow from our cities and towns that scatters in the atmosphere and increases the background brightness of
Right.
the night sky. So it makes it so much harder to see the light from those really distant stars, even impossible sometimes. It's kind of like trying to see a firefly next to a stadium floodlight.
Oh, wow. That's a great analogy. That really hits home, especially thinking about those satellite images in one of the articles,
Right.
like the before and afters. It really shows you how much we've lost in terms of being able to actually see the night sky in more populated areas. But even if we could somehow magically turn off all the lights on Earth overnight, I mean, we still wouldn't see billions of stars, right?
No, because
Yeah.
our eyes have limits. And
Yeah.
I think one of the biology-focused articles you send over touched on that. So, we're only sensitive to a specific range of light. And there are just tons of stars out there that are way too dim for us to see without help.
Yeah.
Either because they're just naturally faint or because they're so incredibly far away.
Yeah, distance, that's a huge one. And I remember one of the astronomy blogs you shared really going into this. Like, the universe is massive, and the farther away a star is, the weaker its light gets. So by the time it reaches us, it could be, I don't know, it could be invisible, practically.
Exactly, yeah. The intensity of light, it decreases with the square of the distance. So a star twice as far away will look 4 times dimmer.
Right.
So for really, really distant stars, the light is it's so tiny by the time it gets here, that exponential drop-off, that's a big reason why we don't see those stars.
And then it's not just, the distance itself. It's like there's stuff in the way, right? Like,
Yeah.
I'm thinking all that cosmic dust and gas.
Oh, yeah, absolutely. Within our own Milky Way galaxy, there are these huge clouds of interstellar dust and gas, and they can absorb and scatter the light coming from stars behind them. So essentially, they just block our view.
Right.
It's kind of like trying to see through a really thick fog.
Yeah.
Some parts of our galaxy are so dense with this material that it completely blocks the light that's behind it. So you can imagine those Webb telescope images you shared. They're looking through these regions in infrared. It's incredible.
So potentially there could be just countless stars hidden from view because of that. Like,
Yeah.
That's mind-boggling.
Yeah.
And then even Earth itself, like our atmosphere, it limits what we can see too, right?
Oh, for sure. Yeah. Yeah. I remember reading that in one of the astronomy overviews you included. Earth's atmosphere is essential for life, but it can also distort and absorb some of that light from space. So the turbulence in the atmosphere, that causes stars to twinkle, which is pretty to look at. But it also
Right.
kind of blurs our vision and limits the detail we can see. And although our atmosphere is transparent to many wavelengths of light, it also absorbs some, particularly in certain parts of that spectrum, the electromagnetic spectrum.
Okay, so our eyes have limitations.
Yeah.
Light pollution is a problem.
Yeah.
Distances are vast, the cosmic dust and gas gets in the way. Our atmosphere is another obstacle.
It's like the universe is
Yeah.
not making it easy for us.
It's really stacking the odds against us seeing the true number of stars just by looking up.
Yeah, our unaided senses only give us a limited view of the cosmos, but that's where science comes in.
Right, exactly. This is where amazing technology comes to the rescue. And those articles about telescopes you shared, oh man, they're incredible.
Yeah.
Telescopes have totally changed our understanding of just how many stars are out there.
Yeah.
They basically take those limitations we talked about and
Yeah.
work around them.
Exactly. And it's all about how telescopes are like light gathering tools.
Right.
So they have these big mirrors and lenses that collect way more light than our eyes ever could, so we can see fainter and farther objects,
Really.
which directly fights that distance dimming. And instruments like the Hubble Space Telescope,
Yes.
which orbits above Earth. It's above the atmosphere, so it's not dealing with all that interference.
Yeah.
That gives us incredibly clear views of the universe.
And then now we have the James Webb Space Telescope. This was like a major thing in so many of the articles you sent over. And this thing, it looks into space with infrared light, which is mind-blowing because that lets us see through all that dust and gas you were talking about earlier.
Mhm.
It basically just opens up these whole hidden regions.
Yeah, the wavelengths we can observe now it's just a whole other ballgame. So infrared light has longer wavelength
Uh-huh.
than visible light, and it's not as affected by the dust, which I think one of your articles on the interstellar medium
Yeah.
talked about. So that means telescopes like the Webb, they can see into those stellar nurseries where stars are born and see galaxies that we couldn't see before. It's almost like putting on night vision goggles that can also see through fog.
That's such a good way to put it. And it really connects back to like why those web images are so groundbreaking based on what I've been reading. And it's not just collecting more light. It's not just about seeing in different wavelengths. It's also things like long exposure photography. I saw that mentioned a lot in those articles about the deep field images.
Oh, absolutely, yeah. Our eyes, they process light super fast, just fractions of a second.
Yeah.
But long exposure photography, that lets telescopes gather light from these really faint objects
Okay.
over much longer periods, like minutes, hours, even days.
Oh, wow.
And so that light builds up on the detector, and then we see objects that would be way too faint
Right.
to see normally. It's really incredible.
So by combining these powerful telescopes with techniques like long exposure photography and the ability to see in infrared and radio wavelengths, I remember that being mentioned in one of the general astronomy articles you shared.
Right.
Scientists have been able to make these crazy detailed deep space images, and they show a universe packed with galaxies. And each galaxy has billions of stars. It's insane.
It really is. And those deep field images, like the Hubble Deep Field and the new ones from Webb, those give us a peek into how dense the galaxies are, even in areas of the sky that look empty. So like each speck of light in those pictures is often a whole galaxy with billions, even trillions of stars. And then by studying the light from these really distant galaxies, we can estimate how many stars there are in the observable universe, which is
crazy.
it's a complicated process, but it's super interesting.
And when you combine all that data, the numbers are they're mind-blowing.
Yeah.
Like you said earlier, for every star we see, there's over 100 million we can't.
Yeah.
That's such a huge difference. I mean, it really puts into perspective just how limited our view of the night sky actually is.
It really does. Like what we think is this limited number of stars is really just the tip of this huge cosmic iceberg.
Yeah.
Most of it's hidden because of everything we've talked about from the research.
And understanding this difference, it has some really deep implications, doesn't it? Like it makes you feel, I don't know, it makes you feel pretty small when you realize how limited our view of the universe is.
It does, yeah. It reminds us that what we see around us is not all there is, Like there's so much more out there that's just operating on these scales that we can barely even imagine.
Yeah.
It makes you feel humble, intellectually humble, and it also shows how powerful science is because it can help us understand things even if we can't see them directly.
It also, like, it makes the universe seem so poetic, right?
Yes, it does, yeah.
Like so vast and so old and just so complex. And it just goes way beyond what we can see or understand. It's almost humbling and inspiring at the same time.
Yeah, it is. When you think about the scale and the detail of the cosmos that science has revealed, it really makes you feel a sense of wonder.
Yeah.
And it reminds us how beautiful and mysterious the universe is, and
Yeah.
that there's always more to discover.
And then there's also the crazy idea that when we look at the stars, that light we're seeing, it's traveled such incredible distances. So we're not really seeing the stars as they are now. We're seeing them as they were hundreds, thousands, maybe even millions of years ago.
That's right, yeah. Starlight has a speed limit, and because distances in space are so vast, that light we see has often been traveling for a really long time. So you could say when you look at a distant star, you're looking back in time.
Wow, that's intense.
Yeah.
So the next time we look up at the night sky, it's important to remember, like, based on all this amazing research, what we're seeing is just this tiny little glimpse, just a tiny fraction of this much bigger and more complex reality.
Exactly. What we see is limited, but our understanding through science and the tools you shared, that keeps growing.
Yeah.
So we're constantly learning more about the true scale of the cosmos.
So the next time you go outside, look up and you see those few thousand stars, just think, I mean, you're really seeing the surface of infinity, like that phrase that,
Yeah.
like, wow, that really changes how you think about the night sky and everything out there.
It really does, and it shows how powerful human curiosity is and how we always want to learn and understand more about the universe, even the parts we can't see. Like this question of how many stars there are, it leads to so much understanding about the cosmos and where we fit in. It makes you want to keep asking questions and keep exploring.
Yeah.
Yeah.
Well, that's incredible.